Okay, here's my concept map, and I begin with plasma membrane, which is selectively permeable. And there are different types of transportation when a membrane is selectively permeable. There's active transport, passive transport, and then there are transport vesicles within the cells that deal with exocytosis and endocytosis. With passive transport, you have different types: channel mediated passive transport, simple diffusion, and then you have a special type of passive transport, osmosis, which only deals with water moving across a concentration gradient. And across the concentration gradient, it can be hypotonic, isotonic, and hypertonic. And what that means is when a cell is hypotonic, there isn't a lot of water molecules inside of the cell compared to outside of the cells, causing water molecules to flow in and the cell will swell. Whereas hypertonic, there's a lot of water molecules in the cell compared to the concentration of solutes, which will cause the water to move out of the cell and it will shrink. And isotonic simply means that the movement of water in and out of the cell is relatively equal. So, going back to the plasma membrane, we have the phospholipid bilayer, which is a two layer a two layer membrane that surrounds pretty much cells, animal cells. And the layer is amphipathic, which means it has a hydrophilic and hydrophobic component. And in this case, the hydrophilic component is the head, and the hydrophobic component is the tail. And within the tail, we have steroids that flow in and out of the cell. But along with the phospholipid bilayer, there are two different models that used to describe it. First was the sandwich model, which isn't relatively used anymore because it was replaced by the fluid mosaic model, which simply states that there are different things inside the phospholipid bilayer, such as glycoproteins and glycolipids, as well as different cholesterols, etc. And in the phospholipid bilayer, usually it's because it's phospholipid, meaning it's fat, it has unsaturated fatty acids and saturated fatty acids. And the only difference between the two is saturated fatty acids don't have double bonds and unsaturated fatty acids do have double bonds. So going down, we have multiple different types of membrane proteins that are either bound in the membrane, or it's simply attached to the membrane and it can unattach itself. So the membrane proteins that are permanently attached to the membrane would be the integral membrane proteins. And they're not permanently attached to the membrane per se, but they are embedded in the membrane. And then you have the peripheral membrane proteins, which attach to the hydrophilic heads of the phospholipid bilayer. And the phospholipid bilayer also has proteoglycan, which serves as kind of a filter between things that are coming outside and things that are coming inside the cells. And there are multiple types of different membrane proteins, as you can see down here. We have monolayer associated proteins, anchor membrane proteins, transport membrane proteins, enzyme membrane proteins, lipid linked membrane associated proteins, and receptor proteins. And that is it. Here it is.